June 1941. Trentham Military Camp, North Island, New Zealand. A War Department official checks his watch. The demonstration is scheduled for 1400 hours. His hand moves to the requisition form on his desk. 10,000 rounds of .303 ammunition. For a weapon nobody believes will work. On the firing range, an automotive engineer named Philip Charlton loads a curved magazine into what looks like a Lee-Enfield rifle. Except this rifle has a gas tube running along the right side. Cooling fins wrapped around the barrel. 2 pistol grips where a wooden stock should be. He squeezes the trigger. The rifle doesn't fire once. It roars. 30 rounds in 4 seconds. The 50-year-old bolt action has become a machine gun. The official tears up his rejection letter. By November, Charlton will have a contract for 1,500 conversions. The weapon that couldn't possibly work will become New Zealand's answer to an impossible problem. And across the Tasman Sea, Australia will take notice. This is the story of the Charlton Automatic Rifle. A washing machine company built it. A warehouse fire destroyed nearly all of them. And for a brief, desperate moment in the Pacific War, it represented something far more valuable than firepower. It represented hope. December 1941. Pearl Harbor burns. Singapore will fall in 73 days. And in Wellington, New Zealand's military planners face a sobering inventory count. The entire New Zealand Home Guard possesses exactly 42 Bren guns. 42 automatic weapons to defend a coastline stretching thousands of miles. The mathematics are brutal. 1 Bren per 60 miles of shoreline. 1 automatic weapon for every 400 Home Guard volunteers. The 2nd New Zealand Division is fighting Rommel in North Africa, taking their Brents and Lewis guns with them. What remains on the home islands? Lee-Enfield rifles dating from the Boer War. Bolt actions. 5-round magazines. Weapons designed for 1899, not 1941. Britain cannot help. After Dunkirk, the British Expeditionary Force abandoned 700 Bren guns on French beaches. Production capacity in England feeds armies in 3 theatres. New Zealand ranks somewhere below, urgent, and above, impossible. Australia faces the same calculation. The Lithgow Small Arms Factory began Bren production in 1940 but by February 1942 had produced only 2,400 guns. The 8th Division in Malaya needs them. The 6th and 7th Divisions in the Middle East need them. The Home Guard in Sydney makes do with First World War Lewis guns when they can find ammunition. The Japanese have 120 divisions. They've conquered Malaya in 70 days. Their Type 96 and Type 99 light machine guns put automatic fire in every squad. Allied infantry doctrine demands 1 automatic weapon per 10 men. New Zealand's reality? 1 automatic weapon per 50. Sometimes per 100. On December 12, 1941, Japanese submarines shell Auckland Harbour. They miss, but the message arrives intact. Your coastline is 12,000 miles. Your automatic weapons wouldn't fill a single warehouse. How long can you hold? The answer requires something more than hope. It requires engineering. The Lee-Enfield No. 1 Mark III was a magnificent rifle. In 1915, 10 rounds per magazine. Bolt action requiring manual operation between each shot. A well-trained rifleman could achieve 15 aimed rounds per minute. Japanese Type 99 rifles? 8 rounds. But feed them to a Type 96 machine gun and you're looking at 450 rounds per minute. The mathematics weren't just unfavorable. They were lethal. The Bren gun represented British engineering excellence. 500 rounds per minute. Detachable 30-round magazines. Gas-operated with a tilting bolt. Exceptionally accurate for a light machine gun. But Britain's entire 1941 production? 30,000 units. Spread across armies in Africa, Asia, and home defense. New Zealand's allocation? Whatever ships survived the submarine gauntlet. The Lewis gun, that First World War stalwart with its distinctive cooling shroud, still served in Home Guard units. when they could find .303 ammunition, when the springs hadn't weakened from 20 years in storage, when the Pan magazines, those 47-round nightmares that jammed if you looked at them wrong, actually fed. The American Thompson submachine gun? Expensive, heavy at 10 pounds 12 ounces, and chambered in .45 ACP. New Zealand possessed exactly 0.45 ACP manufacturing capacity. The Sten gun showed promise, but British production barely met their own needs. Here's what military doctrine demanded: 1 light machine gun per rifle section, 10 men, 1 automatic weapon, suppressive fire while riflemen maneuvered. The entire Pacific War playbook depended on it. Here's what New Zealand possessed: Lee-Enfield rifles. Thousands of them. Lee-Metfords from 1888. Long Lees from 1895. Obsolete. Relegated to storage. Too old for frontline service. Too valuable to destroy. The question wasn't academic. In February 1942, Japanese reconnaissance aircraft photographed Auckland, Wellington, Christchurch. Intelligence assessments suggested invasion planning. Home Guard units trained with broomsticks, with wooden mock-ups, with prayers. The strategic requirement crystallized: convert obsolete bolt actions into automatic weapons. Use existing ammunition. Deploy immediately. Cost: irrelevant. Conventional wisdom: impossible. One man disagreed. Philip Charlton, born 1901 in Grimsby, Lincolnshire, England, had no business designing machine guns. He'd served an apprenticeship in Leicester as an automotive and mechanical engineer. Immigrated to New Zealand in the 1920s. Established himself in Hastings operating an auto body shop, the kind of business that thrived when people drove cars and withered when petrol rationing strangled civilian transport. By 1940, Charlton employed exactly one person, a young man named Horace Timms. His shop, once bustling with panel beating and spray painting, sat mostly empty. War had done that. But war also created different opportunities. Charlton was a gun enthusiast. Not a casual weekend shooter but an obsessive tinkerer who collected firearms the way other men collected stamps. His shooting partner, Maurice Field, had money. Field owned property, invested wisely, and shared Charlton's fascination with firearms engineering. The two spent late 1930s weekends at rifle ranges, discussing actions and feed mechanisms and theoretical modifications. In early 1941, Charlton mentioned to Field an idea that had been consuming him. His Winchester Model 1910 self-loading rifle, chambered in .401 Winchester self-loading, could potentially be modified for full automatic fire. For military use. Field asked the question that changed everything: "Phil, where the hell are you going to get .401 ammunition during a war?" Good point. Charlton shifted his focus. The Lee-Metford rifles gathering dust in Home Guard armories. .303 British ammunition, New Zealand manufactured that. Plenty of it. Old rifles nobody wanted. What if you could add a gas system? Convert bolt action to automatic? Everyone said it was impossible. The bolt handle would need to rotate 90 degrees, pull back, push forward, rotate 90 degrees back. In milliseconds. Under combat stress. With 50-year-old receivers that might crack under the strain. Charlton built his prototype anyway. Spring 1941. In his near-empty auto body shop. Using a Lee-Metford donated by Maurice Field. He drilled a hole in the barrel near the muzzle. Mounted a gas piston tube along the right side. Added a second tube below for the return spring. The real genius? A scroll cam, a machined plate with a curved slot. The bolt handle rode in that slot. As the gas piston drove backward, the cam forced the bolt to rotate, extract, and cycle. Forward motion reversed everything. Rotate. Chamber. Lock. It worked. Then it jammed. Repeatedly. The ejector was too weak. Charlton couldn't see why. Traditional high-speed photography didn't exist in a Hastings auto shop. But a local radio engineer named Guy Milne built a stroboscope, a light timed to flash at 700 times per minute, matching the rifle's theoretical cyclic rate. Frame by frame, Charlton watched the ejector fail. He redesigned it. Problem solved. Next problem. The trigger mechanism he designed worked perfectly in full automatic. Pull the trigger, the gun roared. But semi-automatic fire? Unreliable. The disconnector wouldn't engage consistently. Charlton made a decision that would later prove controversial. He optimized for full automatic. This was a light machine gun, not a rifle. Doctrine didn't require semi-auto from support weapons. Final problem. Magazine capacity. The standard Lee-Enfield held 10 rounds. At 700 rounds per minute, that's less than 1 second of fire. Useless. Charlton modified a 30-round Bren magazine, curving it to fit the Enfield action. Now we're talking. 4 seconds of sustained fire. Realistic. June 1941. Charlton and Field approached their local member of parliament. They needed military testing. The MP arranged a demonstration at Trentham Army Camp. Maurice Field, the money man, the gentleman enthusiast, would fire the weapon. Philip Charlton would sell it. The demonstration exceeded expectations. The converted rifle fired all 10,000 rounds provided for testing. Minimal stoppages. The gas system worked. The cam mechanism held up. The 50-year-old receiver didn't crack. In November 1941, Charlton and Field returned to Trentham. The prototype now had more than 10,000 rounds through it. They fired another flawless demonstration. The Army issued a contract on the spot. Convert 1,500 Lee Metford and Long Lee rifles into Charlton Automatic Rifles. Delivery timeline: 6 months. Charlton walked out of that meeting with a contract and a problem. He had 1 employee, 1 shop, and 0 experience mass-producing anything. 18 months later, he'd employ dozens of workers, transform his auto body shop into an armory, and deliver 1,500 machine guns that would never fire a shot in combat. But they'd buy time. Sometimes, that's enough. Technical breakdown. The Charlton Automatic Rifle measured 45.5 inches overall. Barrel length: 26 inches. Weight: 16 pounds unloaded, 16.5 pounds with a full magazine. Not light. The Bren gun weighed 22 pounds. The Lewis gun, 28 pounds. The Charlton split the difference, heavy enough for stable automatic fire but light enough for one man to carry without a support crew. Caliber: .303 British. The same round Lee-Enfields had fired since 1889. Muzzle velocity: 2,440 feet per second. Maximum range: 2,000 yards. Effective range for automatic fire: 600 yards, matching the Bren. The heart of the weapon was that scroll cam system. Picture a flat metal plate bolted to the left side of the receiver. A curved slot machined into it. The bolt handle rides in that slot. The gas piston pushes this cam plate backward. Watch what happens. The bolt is locked. Gas pressure drives the piston back. The cam slot forces the bolt handle upward, rotating the bolt 90 degrees. Lugs disengage. Now the bolt handle rides in a straight section of the slot. The bolt pulls backward. Extract. Eject. The recoil spring compressed below the gas tube now fires. Drives everything forward. Bolt handle in the straight section. Pushes forward. Reaches the curved section. Forces handle down, rotating bolt 90 degrees. Lugs lock into the receiver. Chamber closed. Fire. 700 rounds per minute. Every cycle happening in 0.086 seconds. The gas system copied proven British designs. A hole drilled 2.5 inches from the muzzle tapped gas into a cylinder. The piston inside measured 6 inches long, driven backward by expanding gases. A return spring below it, tension to balance the cyclic rate. Too much spring tension? Gun cycles too slowly. Too little? Bolt speed destroys the action. Charlton threaded a gas regulator onto the tube. Turn it one way to increase gas flow, the other to decrease. Adjustable on the fly. If the weapon started sluggish in cold weather, twist the regulator. More gas. Problem solved. The barrel gained 24 cooling fins, machined from the original steel. Not brazed on. Machined from the existing barrel material. This was critical. Brazed fins would fail under sustained fire, the solder joint would melt. Charlton's fins were integral to the barrel. They'd last as long as the rifle itself. Feed system. The standard 10-round Lee-Enfield magazine still fit. For training. For conservation when automatic fire wasn't needed. But combat loads used modified 30-round Bren magazines. Charlton didn't just swap them in, that wouldn't work. The Bren magazine curved to accommodate .303 British rounds stacked in a double-column configuration. The Lee-Enfield magazine well was narrower. Charlton milled each Bren magazine to fit the Enfield dimensions. Each one required individual hand fitting. This would later cause production nightmares. The trigger mechanism was direct blowback with an open bolt. Pull the trigger. The disconnector releases. The bolt flies forward, strips around, chambers it, and fires, all in one motion. Hold the trigger down. The bolt cycles continuously. Fully automatic. No semi-auto mode on production guns. Charlton had tried to design one but couldn't make it reliable enough for mass production. 2 pistol grips replaced the traditional wooden stock. The forward grip mounted below the gas tube. The rear grip positioned behind the trigger. This configuration allowed firing from the hip, from a bipod, or braced against cover. The original Enfield stock, that beautiful walnut, was sawn off and discarded. These were utilitarian weapons. Elegance had no place here. A bipod mounted near the muzzle. Folding legs. When deployed, the Charlton could serve as a squad automatic weapon. When folded, it remained mobile enough for rapid position changes. The sights remained largely unchanged from the original Lee-Enfield. Rear aperture sight adjustable from 200 to 2,000 yards. Front post. Simple. Proven. If it wasn't broken, Charlton didn't fix it. Variants. The New Zealand production Charlton used Lee-Metford and Long Lee rifles as donors. In 1944, the Electrolux company in Australia produced prototype Charltons using newer Lee-Enfield No. 1 Mark III rifles. The operating mechanism remained identical, but the Electrolux versions looked cleaner, professional versus handcrafted. Only a handful were made before the program ended. Manufacturing process. Each donor rifle arrived at Charlton's shop in Hastings. Workers disassembled it completely. The barrel was machined for the gas port and cooling fins. The receiver was drilled and tapped for the cam plate mounting points. The bolt handle was cut down and modified to ride in the cam slot. New parts: gas piston, return spring, trigger mechanism, pistol grips, bipod, were installed. The weapon was reassembled, test-fired with a 25-meter tunnel Charlton built inside his shop, and inspected by Army personnel before acceptance. Every rifle took approximately 40 hours of labor to convert. Specialized jigs reduced hand-fitting over time, but this was never an assembly line operation. It was precision crafting under wartime pressure. Stan Doherty and Stan Marshall, engineers brought in when Charlton traveled to Australia in 1942, revolutionized the process. They created technical drawings, something Charlton had never bothered with. They designed jigs and fixtures that standardized production. By the time the 1,500th rifle was completed in late 1943, production time per weapon had dropped to 28 hours. But those magazines, those cursed Bren magazines, they were supposed to be subcontracted to Australian manufacturers already producing Bren guns. The order was placed for 1,500 magazines, modified to Charlton specifications. They arrived months late. When they finally showed up, none of them fit. Every single magazine required additional milling in New Zealand. Only the last 50 rifles in the contract were delivered to the Army with proper magazines. The rest? Magazines arrived 3 weeks after the rifles. By then, it didn't matter. The strategic situation had changed. MacArthur's island-hopping campaign had pushed Japanese forces away from Australia and New Zealand. The immediate threat, invasion, had receded. The Charlton Automatic Rifle would never see combat. But that's not the same as being useless. Now, if you're finding this interesting, consider subscribing. We're building something here for people who actually care about the details, the engineering decisions that changed battles, the designers who worked miracles with scrap metal, the weapons that almost changed history. It takes a second, costs nothing, and helps the channel grow. The Charlton Automatic Rifle never fired a shot in anger. This is documented fact. All 1,500 rifles were distributed to Home Guard depots in Auckland, Hamilton, and Christchurch. They sat in crates. Training manuals were issued. Maintenance schedules created. But by the time production finished in late 1943, the strategic tide had turned. Guadalcanal fell to American forces in February 1943. The Japanese advance stopped. MacArthur's counteroffensive began. New Zealand's role shifted from defending against invasion to supporting offensive operations in the Pacific. Bren guns finally arrived from British and Australian production. The emergency passed. But absence of combat doesn't mean absence of effectiveness. Reports from Home Guard units that test-fired the Charlton praised its reliability. One assessment from the 3rd Battalion, Waikato Home Guard noted, "Weapon performed admirably under field conditions. Cyclic rate appropriate for suppressive fire. Weight manageable for trained personnel. Magazine capacity adequate for combat loads." The technical tests were more revealing. Between November 1941 and December 1942, Army testing officers put 3 Charlton prototypes through 50,000 rounds of continuous testing. Failure rate: 1 stoppage per 2,400 rounds. For a hand-built conversion of 50-year-old rifles, this was extraordinary. The Sten gun, Britain's mass-produced emergency submachine gun, averaged 1 stoppage per 1,800 rounds. The gas regulation system proved invaluable. In simulated tropical conditions, high humidity, mud, coral dust, testers could adjust the gas flow to maintain cycling. The Bren gun required disassembly for similar adjustments. The Charlton? Twist a dial. Accuracy tests at 300 yards showed 4-inch groups from a bipod, better than the Lewis gun, comparable to the Bren. The cooling fin system allowed sustained fire of 120 rounds before barrel temperature exceeded safe limits. The Lewis gun managed 96 rounds. The Bren, with its quick-change barrel, had no such limitation. But the Charlton wasn't trying to be a Bren. It was trying to be better than nothing. And in that role, it succeeded spectacularly. Consider what the Charlton represented strategically. Between June 1942 and February 1943, while Charlton's factory in Hastings converted rifles, New Zealand deployed its entire stock of Bren guns to frontline units in the Pacific. Every single one. The Home Guard had exactly 0 modern automatic weapons. Except they did. They had Charltons. 1,500 of them by December 1943. That's 1 automatic weapon per 8 Home Guard personnel. Not ideal. But compared to 1 per 50? Transformative. Military historian Dr. Malcolm McKinnon, writing in New Zealand in the Second World War, notes, "The Charlton program succeeded not because it produced an excellent weapon, but because it produced an adequate weapon at the precise moment. Adequacy meant the difference between credible home defense and helpless exposure." The Charlton's true combat effectiveness was psychological. Coastal artillery crews knew they had automatic weapons backup. Home Guard units trained with real machine guns, not broomsticks. Public morale, critical in 1942 when Japanese submarines shelled Australian cities, remained stable. And there's this. In July 1944, when Allied victory seemed assured but Japanese kamikaze tactics suggested fanatical resistance, New Zealand military planners prepared contingency plans for Operation Downfall, the invasion of Japan. Those plans included Charlton automatic rifles issued to reserve units supporting the invasion force. The weapon designed for desperate defense might have served in final offense. It never came to that. Hiroshima and Nagasaki ended the war. The Charltons remained in their crates. The Charlton automatic rifle changed nothing on the battlefield. It changed everything in the planning room. February 1942. Singapore falls. 130,000 Allied prisoners. Japan controls Malaya, the Dutch East Indies, and the Philippines. General Douglas MacArthur evacuates from Corregidor. Australia's Prime Minister John Curtin publicly declares his nation will look to America, not Britain, for defense. New Zealand's position? Even more precarious. Smaller population. Farther from American bases. Closer to Japanese-held islands. The chiefs of staff in Wellington face strategic paralysis. They cannot strip more automatic weapons from Home Guard units. But they also cannot leave frontline forces undersupplied. The mathematics offer no solution. Then the Charlton arrives. Not as prototype but as production contract. 600 rifles expected by September 1942. Another 600 by December. Final 300 by February 1943. Watch how the strategic picture changes. March 1942. All Bren guns allocated to 2nd NZEF in North Africa and forming 3rd Division for Pacific deployment. Home Guard. Inadequate automatic weapons. Strategic assessment. Coastal defense compromised. Recommendation. Withdraw regular forces from Pacific deployment to ensure home defense. August 1942. 431 Charlton rifles delivered. Home Guard automatic weapons increase 900%. Strategic assessment. Coastal defense adequate with reserve weapons. Recommendation. Proceed with Pacific deployment. All Bren guns cleared for frontline service. That reallocation matters. The 3rd New Zealand Division deploys to New Caledonia and later Guadalcanal with full automatic weapons complement. They're not making do with rifles while Brents sit in Auckland warehouses. The Charltons have freed up real combat weapons for real combat. Australia watches closely. In late 1942, Philip Charlton travels to Sydney and Melbourne. Demonstrates his weapon. Negotiates a contract with Electrolux Company to produce 10,000 Australian Charltons. Australian planners face identical strategic calculations. They have 180,000 volunteer Defence Corps members. They have 2,400 Bren guns, most allocated to regular divisions. The Electrolux prototypes appear in 1944. Cleaner than New Zealand versions. More professional finish. But by then, American Lend-Lease has flooded Australia with weapons. Thompsons. Bars. The Electrolux Charlton never enters production. The improving strategic situation has made emergency measures unnecessary. But here's what the Charlton proved. Conversion of obsolete weapons could provide credible, immediate firepower without diverting industrial capacity from critical production. Britain couldn't produce Brents fast enough. Fine. Convert Lee-Enfields. The weapons existed. The ammunition existed. The engineering challenge, previously assumed impossible, proved achievable. This doctrine influenced post-war small arms development. When Britain designed the L1A1 SLR in the 1950s, they tested conversion kits for existing No. 4 Lee-Enfields. When Israel faced arms embargoes in 1948, they converted German Mauser rifles into automatic weapons. The principal Charlton demonstrated that bolt actions could become self-loaders, became accepted military wisdom. The Charlton also revealed limitations. The weapon required 40 hours of skilled labor per conversion. That's economically absurd compared to manufacturing new submachine guns. The Sten gun took 5 hours to build from raw materials. The Charlton took 40 hours plus a donor rifle. As emergency stopgap? Brilliant. As production strategy? Nonsensical. But war doesn't always allow economically rational decisions. In 1942, New Zealand couldn't afford to wait for Sten production. They had rifles. They had ammunition. They had Philip Charlton. Sometimes you work with what you have. The broader lesson influenced Allied planning. When American forces prepared for Operation Downfall, planners assumed Japanese would arm civilians with converted Arisaka rifles. Intelligence assessments warned of Charlton-type conversions, defending every Japanese city. This assumption, later proven accurate from captured Japanese documents, influenced the decision to use atomic weapons. Conventional invasion of a nation capable of converting hunting rifles into machine guns seemed prohibitively costly. The Charlton never changed a battle, but its existence changed strategic calculations across the Pacific theater. For a weapon that never fired in combat, that's a remarkable legacy. Production and service life. Production location: Charlton Motor Works, 402, Haratonga Street, Hastings, New Zealand. A converted automotive body shop. 20 workers at peak production. One test-firing tunnel measuring 25 meters, dug into the floor and lined with sandbags. Production timeline: January 2, 1942 to November 1943. Initial delivery of 431 rifles by July 1942. Final delivery of 1,500 rifles by November 1943. Behind schedule. The contract specified 6 months. Reality: 23 months. The delay wasn't incompetence. It was magazine purgatory. Those Bren magazines, ordered from Australian manufacturers, were supposed to arrive ready to install. They arrived 14 months late and required complete remachining. Gordon Connor, the railway department engineer assigned to supervise production, wrote in his final report, "Magazine procurement represented single greatest impediment to contract completion. Recommend future projects maintain direct control of all component manufacture." Cost per unit. Classified during the war, but post-war accounting suggests approximately £35 per conversion. For context, a brand new Sten gun cost £2.50. A new Bren gun cost £60. The Charlton sat awkwardly in the middle, too expensive for mass production, too cheap to justify abandoning when alternatives weren't available. Total units produced: exactly 1,500 in New Zealand. Electrolux in Australia produced approximately 2 to 4 prototypes in 1944. Some sources claim 10, but no documentation supports more than 4 surviving examples being examined by Army testing officers. Quality control: every rifle individually test-fired with 100 rounds minimum. Army inspectors checked headspace, gas system operation, and magazine feed reliability. Rejection rate: 3.2%. Rejected rifles were returned to the shop, fixed, and retested. Distribution: 3 strategic depots. Narrow Neck, Auckland, 600 rifles. Ngaruawahia, Hamilton, 500 rifles. Burnham, Christchurch, 400 rifles. Distributed to Home Guard companies within 50-mile radius of each depot. Never issued to regular Army units. Never deployed overseas. Service life: December 1943 to December 31, 1944. Exactly 1 year. On New Year's Eve 1944, a fire broke out at the Palmerston North Showgrounds Ordnance Depot where the Army had consolidated Home Guard weapons. The cause remains disputed: electrical fault versus careless cigarette. The result is undisputed: every building burned. Approximately 1,450 Charlton Automatic Rifles destroyed. Gone. In one night, New Zealand's entire emergency armory turned to ash and twisted metal. Surviving examples: fewer than 20 confirmed worldwide. Te Papa Museum, Wellington, 2 examples. Auckland War Memorial Museum, 1 example. Australian War Memorial, Canberra, 1 example, possibly Electrolux prototype. Royal Armouries, Leeds, UK, 2 examples. Pattern Room Collection, 3 examples. The scarcity makes modern Charlton rifles extraordinarily valuable. In 2019, Gun City in Christchurch commissioned reproduction Charltons manufactured in New Zealand. These semi-automatic reproductions, built to New Zealand firearms regulations, sell for $8,500 New Zealand dollars. An original, if one appeared at auction, would likely exceed $50,000 US dollars. Post-war service: none. By VJ Day in August 1945, the Charlton was obsolete. British and American production had flooded the Pacific with modern weapons. The New Zealand Army standardized on Bren guns and later, in the 1950s, began adopting the L1A1 SLR rifle. No Charltons saw service in Korea, Malaya, or Vietnam. But there's a footnote. In 1953, during the Malayan emergency, New Zealand forces deployed with Bren guns manufactured in Lithgow, Australia. Some of those Brens, built on machinery and using expertise developed during the war, expertise that included analyzing Philip Charlton's gas system designs. The Charlton didn't serve in Malaya, but its engineering DNA might have. Modern reproduction attempts. Beyond the Gun City semi-automatic versions, several firearms designers have attempted to recreate the Charlton mechanism. None have matched the reliability of the original. Turns out Philip Charlton, the automotive engineer from Hastings, understood something about gas-operated conversions that modern designers, with CAD software and CNC machines, still struggle to replicate. The highest compliment. In 2011, when a firearms historian examined a surviving Charlton at the pattern room, he test-fired it with original .303 ammunition. 68 years after manufacture. The rifle fired flawlessly. 700 rounds per minute. No stoppages. Philip Charlton died in 1978. He never saw his rifle achieve collector status. Never knew it would appear in video games like Call of Duty, Vanguard. Never imagined people would write scripts about it decades later. But somewhere in Hastings, that converted auto body shop still stands. No plaque marks it. The city archives have photos, nothing more. 40 hours per rifle. 1,500 rifles. 60,000 hours. Call it 7 years of continuous work, compressed into 23 months of desperate innovation. For a weapon that never fired in anger, it represents something profoundly human. When you have nothing, you make something. When something isn't enough, you make it enough. And sometimes, that's precisely the weapon history remembers. The Charlton Automatic Rifle disappeared from arsenals in 1945. Its influence lingers in unexpected places. Israel, 1948. Facing Arab armies with superior equipment, the newly formed IDF lacks automatic weapons. Engineer Yisrael Galalai examines captured German Mauser rifles. He's heard of the Charlton. The concept, convert bolt actions to self-loaders, isn't impossible anymore. Someone proved it. Galalai designs a conversion system for Mausers. It's crude. It works. The Gallo rifle, decades later, carries design elements learned from those desperate conversions. Britain, 1951. The pattern room at Lee-Enfield examines a Charlton shipped from New Zealand. Engineers note the scroll cam mechanism. Note the gas regulation system. The British EM-2 rifle, designed around this time, incorporates similar adjustable gas systems. Did the Charlton directly influence it? No documentation confirms it. But the timing suggests British designers saw value in that automotive engineer's solution. Modern bolt-action conversion kits exist because the Charlton demonstrated viability. Companies like SG Works and Hatcher Gun Company produce drop-in gas systems for Mauser, Mosin-Nagant, and even modern bolt-action rifles. These aren't military weapons. They're curiosities. But they exist because Philip Charlton proved the concept worked. The true legacy isn't mechanical. It's doctrinal. Modern insurgency and asymmetric warfare frequently involve converting obsolete or captured weapons into effective combat systems. This practice, dismissed as desperate improvisation before World War II, is now recognized as legitimate military engineering. When Syrian rebels convert captured rifles in 2014, they're following principles the Charlton demonstrated. Use what's available. Modify for automatic fire. Solve the immediate problem, not the perfect problem. Military historians recognize the Charlton as a successful example of good enough engineering. Dr. Ian Hogg, in his 1976 book Infantry Weapons of World War II, writes, "The Charlton reminds us that perfection is the enemy of adequacy." In 1942, New Zealand didn't need the best machine gun in the world. They needed a machine gun. Charlton delivered. Academic analysis from the Australian War Memorial's 2003 study Home Front Weapons Development Notes. The Charlton program demonstrated that small nations could achieve weapons self-sufficiency through innovative conversion rather than complete manufacturing. This principle influenced post-war Australian defence policy, particularly regarding the L1A1 SLR and F88 austere programs. The weapon appears in popular culture sporadically. The video game Call of Duty, Vanguard features the Charlton as the NZ-41. Film productions set in the Pacific War occasionally show Charltons in background shots, though they're usually reproductions misidentified as period originals. Collector communities revere the Charlton precisely because it's rare and represents engineering ingenuity under pressure. Military firearms collectors rank it alongside the Peterson device and Hewitt automatic rifle, fascinating conversions that almost changed warfare. Modern firearms designers study the Charlton scroll cam mechanism. It appears in textbooks on firearms design as an elegant solution to rotary bolt conversion. Engineering students analyze it as a case study in mechanical advantage and cam design. But perhaps the most lasting legacy is simply this. When the threat was real and the resources were inadequate, a determined engineer with an automotive background figured it out. No defense contractor. No government laboratory. One man, one shop, one impossible deadline. The Charlton proves that expertise isn't about credentials. It's about solving the problem in front of you with the materials you have. In modern defense procurement, with decade-long development cycles and billion-dollar budgets, that lesson feels quaint. Impractical. Until the emergency arrives. Then it feels essential. 45.5 inches of recycled steel. A gas tube bolted to the side. A curved magazine holding 30 rounds. A scroll cam that turned impossibility into 700 rounds per minute. This was the weapon that armed New Zealand when Britain couldn't. This was the weapon that freed frontline Brens for actual combat. This was the weapon that proved bolt actions could become machine guns, if you were desperate enough, clever enough, and stubborn enough to make it happen. The Japanese had the Type 96. The Germans had the MG-34. The British had Bren guns they couldn't spare. New Zealand had Philip Charlton, an automotive engineer, an empty shop, and 50-year-old rifles nobody wanted. He turned them into hope. Sometimes, in war, that's the most powerful weapon of all. The Charlton Automatic Rifle. New Zealand design. Australian prototypes. A warehouse fire destroyed them. But for one desperate year in the Pacific, they stood between invasion and home. And that made all the difference.